So when we're trying to make our tree diagram, we've got to think about what happens. So the first stage that happens is that either the mother gives birth to a single lamb, or it gives birth to twins. Okay, so that's the first step, and we're told that 65% of the twins will have, 65% of the sheep will have a single lamb. So we know we've got 65% that'll have a single, and twins is therefore going to be 35%. Okay, then the next layer of the tree is looking whether or not they survive until they're weaned. So we've got our surviving and we've got our not surviving. And if there are twins, now there's three possibilities. It could be that both of the twins survive, it could be that one of the twins survives, or none of them. So we can say 2 survive, 1 survives, or 0 survives. Okay, and we have been told that if they get a single lamb, then 86% will survive. So there's our 86%, so you've got that part fine. And therefore that's going to be the 14%. Then we've also got, of the ones that make twins, 1 in 5 lose both their lambs. So 1 in 5 don't survive. So that's 1 in 5 don't survive. And then we're told equal numbers of one or both twins survive. So if 1/5 is that section there, that means 1 surviving and 2 surviving, that has to add up to 4/5. Because remember, all 3 of those probabilities add up to 1. 1 take away 1/5 will leave me with 4/5. And then I'm going to split that into 2, and that means there's 2/5 where 2 survive and 2/5 where 1 survive, and then those are my probabilities. All right, so that's the part of the tree that we need to make sure we get correct. Once we've got that, then we look at the actual question. So it's talking about the probability that a randomly selected lamb survives until it's weaned will be from a ewe that produced a single. So you've identified correctly that you want the probability of a single that survived divided by the probability of a total that survived. Okay, so you've got your single surviving correct. So if I jump back to there, that single surviving, that is the 0.65 times the 0.86. So that is all good. So that's 0.65 times 0.86. Okay. All right, but it's the total surviving that we've got to look at. All right, so I'm just going to clear that up the top there, and I need to look at the total surviving. So the total surviving could be, oh, that's not going to do what I want. Let me change that to, change that colour to there. Okay, so I'm looking at surviving. So either it's a single who survives, or it's a twin who survives, where 2 of them survive, or a twin where 1 of them survives. So there's 3 different combinations that we've got to take into account, not 2. And the extra factor that we've got to take into account is when we're talking about 2 surviving, you've got to multiply that by 2 because there's 2 lambs there. Okay, so to get the total surviving, we need to do the 0.65 times the 0.86, 0.86, plus we've got to do twins where 2 survive, so twins is 0.35 times 2/5, and that's where twins both survive, so you're multiplying that by 2, plus you're going to do your twins where 1 survives, so that's 0.35 times the 2/5. And so when you combine when you add all that together, then that's going to give you a probability of where is my sheet? 979. And when I divide those out, that'll give me 0.571 as my probability.